Look at this diagram. This diagram is for failure mode effect analysis. F for failure, M for mode, E for effect, and A for analysis. FMEA is one of the qualitative tools which support proactive quality strategies. So proactive means before happening we have to stop. Before happening the hazardous events, we have to find it and eliminate it. This is called proactive method. In this method, various parts or components of the system and their modes of failures are studied. The causes of failures and interrelationship between the components are not studied. We don't want the causes of failures. Okay. So how likely they are going to occur? Their modes of failures are studied. FEMA is defined as it is a systematic tool to identify possible failure modes, to understand failure mechanism, risk analysis, and plan for action. It is one of the most popular methodology for analysis and failure risk of systems. It is a qualitative method. Also, it is a quantitative method and corrective method too. FEMA is a tool for risk analysis and management in both project and process phases. It is a tool for risk analysis in both project and process phases. It allows the evaluation of other aspects such as maintainability, safety, and so on. It is a failure prevention tool. So this is very important tool, very effective tool also, because failure prevention can be predicted in advance and it can be eliminated to avoid losses. So this table shows the modes and functions of FEMA, that is failure mode effect analysis. So the failures and failure mode, effect, everything is given in the table, and using this table the analysis can be done. Next one, fault tree analysis. It is a graphical tool to explore the causes of system level failures. Previously we don't want causes of failures, but in fault tree analysis the causes also studied. It uses Boolean logic to combine a series of lower level events, and it is basically a top-down approach to identify the component level failures. It consists of two elements. It is events and logic gates, which connect the events to identify the cause. It is a technology-based deductive logic. The failure is initially defined and the events leading to that failure are identified at different components level. So, as I said, the failures as well as the causes are also analyzed. This method can combine hardware failures and human failures. Some failures may happen at human level, human errors. Some may occur due to the machineries. So you combine these two, hardware failures as well as the human failures. An automobile car does not start. The details of this case are shown in figure. This is the example for fault tree analysis, where the events are analyzed to find out where the failure is and what are the causes of failure. The car is not starting means it may be due to human error, or it may be due to the machine, that is engine error. These two are possible for not starting the car. So we have to analyze both human as well as the machine faults. See, as I told you, some failures along with this logic gates are combined, and this kind of fault tree analysis done for risk assessment. Event tree analysis. Next one, event tree analysis. It is a forward top-down logical modeling technique for both success and failure that explores responses through a single initiating event. Shortly we call it as ETA. Event tree analysis uses inductive logic, mainly used for consequence analysis and in analyzing potential hazardous existing situation in the system. So we are going to analyze the existing situations, hazardous situation in the industry or any workplace. At that situation, this kind of logic, this kind of event tree analysis will be helpful. It is the inverse of FTA, fault tree analysis. It is the inverse of fault tree analysis. ETA allows the observer to proceed forward in time from potential component failures to final accident. At the time of finding the initial component failure, the ETA, event tree analysis, will give the proper outcome. So, from the basic level, component level failure to final accident can be assessed. This is the advantage of ETA, event tree analysis. Another example for event tree analysis is given. This car starts. Yes, if the car starts, whether highway is clear or not. Highway is clear, yes. Late for duty? No. Car is starting, so I am driving a car. The highway is also clear. There is no traffic. So I can go to the college or office in time. No late. Car is starting, but the traffic is heavy at the highway. Then there will be a delay in reaching the college or institution or office. Car is not starting. Okay. If the car is not started, what I can do? Either I can go for by bus or train. Train bus available? Yes. Means there is no delay. I will reach in time. Train and bus not available. Not available means I have to go for the next one. Colleague available? Yes. My colleague is there. He is residing very near to me. I can go with him in his vehicle. Highway is also clear, so there is no delay. My colleague is having, but the highway is heavy traffic, then there will be a delay. Colleague is not also having a vehicle, then there will be a delay. Okay, so this is the event tree analysis for risk assessment. The steps for scenario building may alternatively be detailed as identify the hazard of interest, state the question to be investigated, develop the planned scenario. This has been already studied. Safe exit. In the study of safety, the safe exit principles are recommended. Safe exit means the product when it fails should fail safely. The product when it fails can be abandoned safely. User can safely escape from the product or site. Evacuation. Safe evacuation should be there. This is called safe exit. The categories of consumers are seasonal consumers, personal consumers, organizational consumers, impulse consumers, need-based consumers, discount-driven consumers, habitual consumers. Okay. So these are the categories of consumers. The safety and risk must be assessed in such a way that it should not harm to the society, it should not harm to the public, it should not harm to anyone. The remaining things we will see in the next PPT. I will tell you the introduction of risk-benefit analysis. We will see the risk-benefit analysis in depth in the next PPT. So what is the risk-benefit analysis? It is a method that helps engineers to analyze the risk in a project and to determine whether the project should be implemented or not. Okay. If risk is there, we have to follow some methods to reduce the risk, or we have to inform the engineers to analyze the risk in a project and to determine whether the project should be implemented or not. Whether we are going to drop it or whether we are going to continue it. We have to decide. What are the reasons for risk-benefit analysis? Risk-benefit analysis is concerned with the advisability of undertaking a project. Some risks are there, no benefit, then we have to drop it. Even though there are some risks, benefits are more, we can continue. So, this kind of analysis can be done. It helps in deciding which design has greater advantages. It assists engineers to identify particular design scores higher with that of the other. So, engineers must also identify the particular design with high score. This is very important.